Welcome to our latest video on alkenes. This video is suitable for GCSE students. By the end of this video lesson, you should understand that alkenes undergo addition reactions with hydrogen and bromine, and that the reaction with bromine is used as a chemical test for an alkene. You should also be able to use structural formulae and balanced equations to describe what is happening in addition reactions. And you should understand that alkenes are used to make polymers in a process called addition polymerization. In our previous video lessons on hydrocarbons, we've learnt that alkenes contain a carbon-carbon double bond, and they have the general formula CnH2n. Now this means that however many carbons you have double the number of hydrogens. Now the simplest alkene is ethene, and its molecular formula is C2H4. Now this slide also shows its structural formula, and you can see clearly that it has a carbon-carbon double bond and 4 single covalent bonds to hydrogens. So now let's look a little bit more closely at the bonding in alkenes. So an alkene has a carbon-carbon double bond, and that means that if we look at our bonding diagram, the carbon is sharing 2 pairs of electrons with another carbon atom. That is what we mean by a double bond. It's sharing 2 pairs of electrons. And each carbon is also sharing a pair of electrons with 2 hydrogens. So therefore, each carbon has a share of 8 electrons. It has 4 electrons in its outer shell, and it's sharing 2 pairs of electrons with 1 carbon, and it's sharing a pair of electrons with each hydrogen. And both the carbon and the hydrogens in this diagram are obtaining their full outer shells. Now every alkene contains a carbon-carbon double bond. And the full structural formula here of ethene shows this clearly because it's represented by 2 lines. A single line is a shared pair of electrons, a single covalent bond. A double line represents a share of 2 pairs of electrons and a double covalent bond. Now in our previous lessons on hydrocarbons, we've learnt that the molecular formula simply states the number of each type of atom present in the molecule. So the molecular formula of ethene is C2H4 because there's carbon and hydrogen atoms, and there's 2 carbons and 4 hydrogens. And the molecular formula of propene is C3H6 because there's 3 carbon atoms in each molecule and 6 hydrogens in each propene molecule. Now in organic chemistry, chemicals from oil, it is often more useful for you to draw the structural formula, because the structural formula shows the arrangement of atoms within that molecule. And the structural formula of both ethene and propene is shown on this slide. And this shows clearly that both are alkenes because they contain a carbon-carbon double bond. Now in our previous videos, we've also taught you how to name basic alkanes and alkenes. And we've discussed the fact that the first part of the word tells you how many carbons present. So if, for example, you have a compound with a name that starts with BUT, that means there are 4 carbons in that molecule. Now the second part of the word tells you whether it's an alkane or an alkene. So if it ends in ANE, that's an alkane, and if it ends in ENE, that's an alkene. So an alkane with 4 carbons is called butane, and an alkene with 5 carbons is called pentene. Now in our previous video lesson on cracking and the properties of hydrocarbons, we learnt that in an oil refinery, long hydrocarbon chains are broken down by heat and a catalyst in a process called cracking, and this leads to shorter chained alkanes that are more useful because they're easier to boil, easier to burn, and easier to pour. And in addition to this, you get an alkene produced. So cracking is a major way that alkenes are produced in chemistry. Now in this video, we're going to focus on alkenes in a lot more detail. Now alkenes are very reactive, and this is because they're unsaturated. They contain a carbon-carbon double bond. And alkenes have a general formula CnH2n. So however many carbons you have double the number of hydrogens. Now alkenes do burn to give out energy. However, they burn with a smoky flame, producing lots of soot. So they aren't very good fuels like alkanes, which burn cleanly. Now because alkenes are very reactive, they're used to make lots of different products in the chemical industry. For example, alkenes are used to make alcohols. They're also used to make polymers, long chain molecules, such as polyethene, polypropene, PVC, polyvinyl chloride, polytetrafluoroethene, PTFE or Teflon, and polystyrene. Now these polymers are commonly known as plastics, and we'll be discussing these in future videos in great detail. Now in this video, we're going to look at the reactions of alkenes. Now alkenes are much more reactive than alkanes due to the fact they have unsaturated carbon-carbon double bonds. Now alkenes undergo addition reactions, and these are reactions where two or more reactant molecules join together to form a single product. Now a good example of an addition reaction is the reaction of alkenes with bromine. Now if you look at this equation, we have ethene reacting with bromine. Those are our two reactant molecules, and they join together to form a single product. And our single product is called dibromoethane. Now its exact name is 1,2-dibromoethane because the bromines are on carbons 1 and 2. However, in the exam, it is perfectly fine to call it dibromoethane. Now if you look closely at the equation, you can see that the double bond in ethene is broken in the course of the reaction. And therefore, we have ethene that has a double bond, but our product is made up of all single bonds. It is said to be saturated. And that's what happens in an addition reaction. The double bond is broken, and the other molecule just joins onto the alkene. And it can do this because the alkene has spare bonds because of the double bond. And that's why the alkene is very reactive. Now this reaction is very important in chemistry because it's a test for a carbon-carbon double bond. It's a test for an alkene. Now bromine water is orange, and if you add this to an alkane and shake it up, the alkane will stay orange because no reaction takes place. But if you add the bromine water to an alkene, because the bromine adds to the alkene to form a new product, the alkene goes from orange to colourless because a chemical reaction has taken place. So you have to learn that if you want to test for a double bond in a molecule, a carbon-carbon double bond, you add bromine water and shake it up. And if it goes colourless, it means that you have a carbon-carbon double bond, and that compound is an alkene. Now to help you understand how addition reactions work, I've made some molecular models. So I've made a model of ethene, and it has a double bond. And I've made a model of bromine, and it's got a single covalent bond holding the atoms together. Now in an addition reaction, the double bond of the alkene breaks. So if I break my double bond, I also need to break the single covalent bond that was holding the bromine atoms together. And then all that takes place is that the bromine atoms add either side of where the double bond used to be. So when I break my double bond between the two carbons, I now have a single bond between the two carbons, and I add the bromines one atom at a time onto each carbon. So if I draw out the structural formula, you can see I've broken the double bond of my ethene molecule, and I'm going to add the bromines either side of where the double bond used to be. So one bromine goes onto one carbon, one bromine atom goes onto the other carbon. Now my product is called 1,2-dibromo ethane, and it's called dibromo because di means two and there's two bromine atoms in this molecule. Now the reason it ends in ane, A-N-E, is because my product is saturated like an alkane. It doesn't contain a double bond anymore, and that's why the product is called 1,2-dibromo ethane. Now this reaction is called an addition reaction because two reactant molecules have joined together to form a single product. Now a second example of an addition reaction is the reaction of alkenes with hydrogen. Now alkenes will react with hydrogen in the presence of a catalyst, and this reaction also requires high temperature and pressure. Now if you look at the equation, we have ethene plus hydrogen goes to ethane. So I have C2H4 plus H2 goes to C2H6. Now this reaction, like every other addition reaction, involves the double bond of the alkene breaking, and it's an addition reaction because two reactant molecules have joined together to form a single product. Now this reaction is also classed as a reduction because reduction is a term that we use for a loss of oxygen, a gain of electrons, and a gain of hydrogen. So as there's a gain of hydrogen here, ethene is being reduced. Now this reaction is particularly important commercially in the margarine industry because unsaturated oils which contain lots of double bonds, are saturated by adding hydrogen to make saturated fat, which is a main constituent of margarine. So let's once again use the molecular models to understand how this reaction works. So if I start with ethene, I've got my carbon-carbon double bond, and like all addition reactions, I need to break this double bond, and then I also need to break the single covalent bond that holds hydrogen atoms together, and then the hydrogen atoms join either side of the double bond. So I've got an addition reaction because I've ended up adding two molecules together, joining two molecules together, and I get a single product. And my single product is now saturated because it's made up of all single bonds. And in this reaction, my saturated product is called ethane because ethene plus hydrogen makes ethane. And its molecular formula is C2H6, and its structural formula is written there with all the bonds shown, and you can see clearly that it is a saturated molecule consisting of all single bonds. Now in the next section of this video, we're going to look at how alkenes can be used to make plastics and polymers. Now plastics are made from crude oil, and plastics are made by joining small molecules together to form long-chained molecules. And any long-chained molecule is called a polymer. Now the plastic polyethylene, commonly known as polythene, is made by joining thousands of small ethene molecules together. And the small molecules are joined together to make a polymer are called monomers. Now when ethene joins together with other ethene molecules to make a long-chained polymer, the type of reaction is called addition polymerization. Polymerization is making a polymer, and an addition reaction takes place when lots of ethene molecules join together. So this slide summarizes what we mean by monomer and polymer. So if we join lots of ethene molecules together, we make a long-chained molecule. That is called a polymer. And each ethene molecule is called a monomer. Now mer means unit. Poly means many. So many units, polymer. Mono means one. So that's why one ethene molecule that can be joined with other ethene molecules to form a polymer is called a monomer. Now when naming a polymer, you put the word poly and then in brackets you put the name of the monomer. So polyethene is made by joining lots of ethene molecules together. So that's why the polymer is called poly and in brackets ethene. So now let's use our molecular models to explain how alkene molecules can join together to form a polymer. So I'm going to start with just 3 ethene molecules, and I've made models to represent them, and I've drawn their structural formulae. Now remember, when alkenes react, the double bonds break. So I'm going to break the double bonds of my 3 ethene molecules. Now if I break the double bond on each molecule, I generate a spare bond that can be used to join the molecules together. So I'm then able to join the 3 molecules together to form a longer chain. Now this longer chain contains all single bonds and is therefore saturated. Now I'm now going to draw out, using structural formula, what this hydrocarbon chain looks like. And to do this, I'm going to take my 3 alkene molecules and I'm just going to break the double bond, and therefore I generate my spare bond, and the spare bond is used to join the molecules together. Now when I had 3 alkene molecules, I generated this saturated chain of 6 carbons and 12 hydrogens. Now you can see clearly that this unit is just simply repeated 3 times, and this unit is C2H4. Now this is called a repeating unit. Now the reason the repeating unit was repeated 3 times in my finished structure was because I had 3 alkene molecules joining together. Now if I'd had 1,000 ethene molecules joining together, that repeating unit would be repeated 1,000 times. Now it's typical for polymers to have hundreds of thousands of alkene molecules joining together. So therefore we have to have a way of representing polymer formation. And this equation represents how polyethene is formed. So if I have N ethene molecules, so I put N in front of the structural formula of ethene, I would have this repeating unit repeated N times. Now the size or value of N tells you how long the polymer is. So if, for example, N was 1,000, that means that C2H4 is repeated 1,000 times. However, if N is 1,000,000, it's a much longer polymer because C2H4 is repeated 1,000,000 times. Now the repeating unit is C2H4, and N tells you the degree of polymerization. It tells you how many times that repeating unit is repeated. It tells you how long the polymer chain is. As I've said previously in this video, polymer chains can be incredibly long, and sometimes repeating units are repeated hundreds of thousands of times. Now this process, where lots of alkene molecules join together to form a long saturated hydrocarbon chain, is called addition polymerization. And addition polymerization, just like addition reactions, work by the double bond being broken. And in addition polymerization, the double bond breaks and the spare bond that is generated is used to join the different molecules together. Now in our next video, we're going to look at addition polymerization in more detail, and we're going to look at a number of examples of addition polymers and discuss their properties and uses. However, in the rest of this video, we're going to look at polyethene, its uses, and then look at some past paper questions on this topic to test our understanding. Now, polyethene is used to make lots of different products. For example, it's used to make carrier bags, it's used to make washing up bowls, it's used to make plastic buckets, it's used to make food wrap, and it's used to make drinks bottles. And the reason it has these uses is because it's strong, it's light, it's waterproof, it's flexible, it's cheap to make. These are just some of the reasons why polyethene has these uses. However, it does have disadvantages and major disadvantages. For example, polyethene, like most plastics, is not biodegradable. This means it doesn't rot away. And therefore, if you put it in a landfill site and try to dispose of it, you would find it would still be there in 100 and 1,000 years' time. And that means that when we try to dispose of polyethene, it is filling up landfill sites because it's not rotting away. Now, these plastics are difficult to dispose of, not just because they're not biodegradable, but because when you try to burn them, they give off toxic fumes. So therefore, it's very, very important that we recycle plastic, because one, we are saving the environment because we're not filling up our landfill sites, and two, we are saving energy because it takes less energy to recycle plastics than it does to make plastics from scratch. And three, we are reducing our crude oil consumption, and crude oil is a non-renewable resource that is going to run out. So we're now going to test your understanding of the topics covered in this video with some practice questions. So here's our first practice question, and this comes in 3 parts, and part 1 and part 2 is on this slide. So read through the question, pause the video and have a go at it, and then we'll look at part 3. So here's part 3. Once again, read through the question, pause the video, have a go at it, and then we'll go for the answers to parts 1, 2 and 3 together. So now let's go for the answers to question 1. So for 1A part 1 is asking you to draw the structural formula for hydrocarbons B and C in the boxes below. So for B it is C2H4, so that is an alkene. And you know this because an alkene has double the number of hydrogens to carbons. So the structural formula is a carbon-carbon double bond and then 4 CH bonds. So I've drawn that in the box for B. And then C is C2H6, so that's an alkane. And you draw all single bonds joining the carbons and hydrogens together. And then for the second part, it's asking you to name the family that they're from. So B is an alkene and C is an alkane. So part 3 is asking you to give the letter of the hydrocarbon which reacts with bromine to form the compound below. So that hydrocarbon would be B, 1 mark for that. And its reason is because B is the only alkene that was drawn, and bromine reacts with alkenes. It's a test for an alkene, and B is the only alkene, so there's a mark for that. And then it says, give the term used for this type of reaction. It's an addition reaction. 1 mark for that. So now have a go at question 2. So part A is asking you to give a balanced symbol equation for the reaction between ethene and bromine. Now you can draw structural formula to represent these compounds and the product that would form. And then it says describe the observation made during this reaction. So read the question, pause the video, have a go at it, and then we'll go for the answers. So here's the answer to question 2. You're asked to give a balanced symbol equation for the reaction between ethene and bromine, and you can either write down C2H4 plus Br2 goes to C2H4Br2, or you could draw the structural formula to represent this equation, like I've done on the screen. So you could draw a carbon-carbon double bond with 4 CHs plus Br2, and you could draw out dibromoethane. Now there's 1 mark for the reactants, getting them correct, and 1 mark for the product. And then the second part is asking you to describe the observation made during this reaction. So this question is about you knowing that bromine water is a test for an alkene. So it would go orange to colourless. Now if you got that right, there's 1 mark for that. So in total, this question is out of 3. 2 marks for the equation and 1 for the observation. So now have a go at our last question, question 3. And this comes in 2 parts. And this slide has the first part. So read through the question, pause the video, have a go at it, and then we'll look at the next part of the question. So here's the final part of question 3. Once again, read through the question, pause the video, have a go at it, and then we'll go for the answers. So let's go for the answers to question 3. So 3 part 1 is asking you explain the meaning of the term unsaturated. And unsaturated means it contains a carbon-carbon double bond. 1 mark for that. And then it says one method of producing ethene is by cracking of large saturated hydrocarbons. Give 2 conditions needed for cracking. So heat and a catalyst, 1 mark for each. So let's go through the last part of question 3. So you're asked to draw a symbol equation for the production of polyethene from ethene. So if you drew the correct repeating unit, you get 1 mark, and I've drawn that here. And you get 1 mark for putting the N and getting in the right position. And then it's asking you to give 1 reason why people are concerned about the use of plastics, such as polythene. But if you said they're not biodegradable, or they build up in landfills, that would get you a mark. And you could also write down that they give off toxic gas when burnt, and therefore they're difficult to dispose of. We'd accept that as well. 1 mark for that, and 2 marks for the symbol equation. So that part of the question is out of a total of 3 marks. So that completes our video lesson. So after watching this video, you should now understand that alkenes undergo addition reactions with hydrogen and bromine, and that the reaction with bromine is used as a chemical test for an alkene. You should also be able to use structural formula in balanced equations to describe what is happening in addition reactions. And you should understand that alkenes are used to make polymers in a process called addition polymerization. So that concludes our video. Please check out our YouTube channel, Dr. O Chemistry, and our Twitter site, which contains lots of chemistry information and links, at Radachemistry.